Okay, our question is for 105. Question is like this: replace the loading system acting on the post by an equivalent resultant force and couple moment at point P. Now, certainly we have a force acting at point P. Its magnitude is 30 kilonewtons. Then we have another force, second force, which is 60 kilonewtons. It makes an angle of 3, 4, 5 with respect to the vertical axis. Then we have a 40 kilonewtons of load in the horizontal direction. The distance from the bottom to its third force is 2 meters. Distance from P to the third force is 4 meters. Distance of second force from the point P is 1 meters. And we are asked for the resultant force that acts at point P and the moment at point P. Now the point is, instead of using the coordinate system given by the problem, I will use a different coordinate system. Certainly, I will choose the x coordinate, horizontal, but y coordinate, vertical, but downwards. And I put this new coordinate system at point P. Now I need to define the forces and position vectors with respect to this new coordinate system, and then I will write them in Cartesian form, and I will calculate the resultant force in Cartesian form and the moment. Let's see how we can do it. So this is my free body diagram. In fact, I have force 1, I have force 2 and force 3. Certainly I have the position vectors R1, R2 and R3. Now in fact F1 is 30J kilonewtons, F2 is equal to minus 36I plus 48J vector, and F3 is equal to 40I kilonewtons. Now the position vectors are like this. I have R1, it is 0I, 0J. R2 is equal to 1J, and R3 is equal to 4J. Now, if I do the calculations, if I sum up all the forces, so minus 36 plus 40 will make 40I vector. Now, the second thing is in the y direction, I have 30J and I have 48J here. So the resultant is 78J, and the unit is kilonewtons. Now I have to calculate the moment with respect to point P. Therefore, I write all the position vectors with respect to point P. In fact, force 1 will not generate any moment at point P because it directly acts at point acts on point P. So the moment generated by force 2 is R2 vector product F2, and the moment generated by force 3 is R3 vector product F3. Now it is 1J multiplied by 36I plus 48J. This is this one. And then I have this operation, R3 vector product F3 is 4J vector product 40I. Now, if I consider that Z-axis is towards the, or through the screen, inside the screen, then according to the right-hand rule, as you see, I put my elbow on the y-axis and I curl my fingers towards x-axis. In fact, my thumb shows the direction of the resultant vector. So it is in the positive z direction. Therefore, this vector multiplication, j multiplied by I, will make positive k, and 1 multiplied by minus 36 will make 36k vector. Here, j multiplied by I will make positive k. 4 multiplied by 40 will give you 160. And as a result, the resultant moment is 124 k vector, and the unit is kilonewton meters.